Right, write this down. I'm waiting for you.
No,
Write this
I'm
down.
waiting
Did you
for
write this
you.
down?
Nearly.
Okay. This lesson, nice, easy lesson. We're learning how to make an important graph. Okay, so nice and easy for this one. IV characteristics. You got that? Yeah. So we'll be talking about Ohm's law. So here's a very simple circuit here, and I want us to talk about what happens when you change the resistance here. So I want to know what happens to the voltage and the current around the resistor. Okay. So firstly, to make it easy, let's just imagine this is 12 volts, for example. This is 12 volts. Okay. So will the voltage be the same or different in this resistor and this resistor?
Same.
No, different. Because what's the formula for voltage? V equals I times R. Yeah. Now, will the I be the same or different?
Same.
Different.
I is always the same in series.
No.
Yes. Yes.
Yeah.
I in yeah. So the I, we're agreed the I is the same. True?
Yeah.
True. The R's are different because you can change this one.
Yes.
So I or the same or different? Different. So the voltages are of course different because they're in series. But they must add up to 12. If you increase the resistance here, you make the R bigger, what happens to IR? It gets bigger.
Yeah.
So what happens to V? Gets bigger. So what happens to the voltage here?
It's smaller.
Gets smaller. So by changing this, you can change the voltage and the current would also result in a change. In other words, you're able to measure the relationship between voltage and current for this particular resistor. You can make a graph of what is the voltage and current at different points. This is an extremely important graph, and this circuit is extremely important circuit. So please write this, draw this circuit carefully in your notebook. It's a very important circuit. What? There you go. Right, did you draw this?
No.
Not yet. Tiredly? Bored? You're an honest man. I like that. Okay, did you draw that? Yes? Omar?
Yeah.
Okay. So, let's have a look at the graph. Here's an example. I've collected some data. The voltage was 10, and then it decreased to 1 because I increased the resistance on the rheostat. And what happened to the current what happened as I decreased the voltage? The current decreased as well. I want to plot this now. What should I put on the X and what should I put on the Y? And before you say anything,
Both.
what? Put both on the X, is it?
No, you can put any.
No.
I swear you can.
Well, I know there's no reason the voltage couldn't go on either of them because it's not like it's going to fall off the page. But there is one more appropriate to put on the X, which is that.
Voltage.
Why?
Because it's in series. It has a
No, that's not the reason.
There's a light going up.
It's
No.
independent value.
Yeah.
Which means what?
You can't
It
control
will
it.
change.
You can't control it. The y-axis is the thing that you can control and change.
Yeah, keep it simpler though. You put the voltage on the X because...
It's an independent variable.
Yeah, but Fuang won't know what that means. What's an independent variable?
It
Exactly.
doesn't-
So,
it
something
depends
else.
on something.
No. Something else. Easier, come on.
You can't control it.
No, easier than this.
Okay, we don't know.
Alright, you put... Yes?
Well, because like you can increase the volts and decrease it.
Now we're getting closer. The voltage goes on the X because the voltage is the one you change. So whatever is the one you are changing, that goes on the X.
But you're not changing the voltage.
You are, by changing the resistance in the rheostat, it's causing a voltage change. Now you can get machines that you can just change the voltage by turning a dial. This circuit is pre-digital age. So this is how you would change the voltage in the past. So it's a historical circuit as well. So the voltage goes on the X and the current goes on the Y. Let's make this graph. I'll make the graph, but I need you to copy this table into your notebook as an example.
Copy.
Yeah, guys. I have my two best note takers up the front of the class making notes.
Only the first two.
He could do the first row and then you could copy the second row, and together it could be a complete notebook.
Why are you drawing the graph? Draw the table.
He's right, he can see what's happening, yes. No.
What's no?
Your graph you drew. Let's see it. Where is it? No.
Yes. He plots the axis.
Shape's wrong.
Not no.
This is going to end awkwardly for one of us. We shall see who in a moment. Okay. Do you who is it going to end awkwardly for?
Huh?
Guy with the master degree.
I know I'm not perfect, but I feel confident that that's the wrong graph here. Okay, do you copy the table? Let's make the graph. So we haven't actually, we have talked about making graphs when we made the velocity time graph. So we need voltage. Another name for voltage is potential difference. I'll just call it voltage, and the unit is volts. And here we have current, and the unit is amps. Yeah. Voltage starts at 10 and decreases by 1 each time, is it? Until 1. And then what is the current doing? What to start with? 20, and it reduces by 2 each time, is it? Until it is down at 2. Okay, so I would like you to copy the graph. You won't be surprised by what you see. But again, it's good to practice drawing graphs in physics. Make sure you have everything right. So it's actually technically called a scatter plot. I don't like legends. The title, P-H-U-O-N-G, is it?
Yeah.
Okay, great. No. This is current against voltage. Important. No, forget it. No supply. The X is volts, I amps. And here it is here. Similar to your graph.
But isn't it not straight?
In this one it is, and we'll discuss that in a moment. For this resistor it is straight. So in
it
fact,
doesn't get affected by temperature.
not at the range we're looking at.
Drawing resistance and temperature.
Well, there you go.
Yeah.
How embarrassing. You'll have to have a Facebook post about this when you get home.
Let's see what.
OMG, totes embarrassing, mixed up physics graphs, YOLO, hashtag physics. Right, can you draw this
Right
in?
now.
Can you draw this in your notebook, please? So as Faisal noted, you get a straight line graph here.
Get off.
It's okay, you can just do a nice sketch. But in the exam, they want it on graph paper. Nice, neat, clear graph.
So do we,
But for your notebook, you can just do a sketch. Have the numbers on it too, please. Please, some numbers. And
Hashtag what?
hashtag Stephen DIFC physics? I don't know.
your YouTube channel?
Oh yeah. It doesn't matter.
Advertisement.
Math
You have a
drawing?
lot of followers.
Yeah.
Grind
With S.
and maths with an S.
Yep. Because, Irish. Not American.
I hope no one asks about this.
Oops. Just trying to move this a bit to the... Okay. Do you have this? Yeah? Yes? Now, let's have a look at what the slope represents. What? No.
Isn't R equals V over I?
This is I, this is V. The slope is I over V. Now, if you think about your triangle, what's resistance?
V over
V
I.
over I.
So the slope is 1 over R. Yeah. That is worth noting. I might have said it on the next table. Not yet. Please note that the slope of this graph, so you could say the resistance is 1 over the slope. Extremely important. What?
Trick question.
You have a trick question for me? Thanks for warning me that's a trick question. Go ahead, what's your trick question?
Not very tricky. Why don't we graph V over I?
We can, and the slope would be R. But for experiment purposes, it's more appropriate to put the independent variable on the X. Wow.
They want to make it appropriate to fly a kite under a thunderstorm. It is. But making...
As long as you take the right safety precautions, it is. Okay, did you make note of this? Now, this graph has a special name. This is called the IV characteristics. It's actually just the plot that I showed you. So if I said, what is the IV characteristics of this resistor? It means plot the I and the V. So literally, the name of this type of graph is IV characteristics graph. Or even just IV characteristics.
We have to write all stuff.
I would like you to write all of this. Feeling better, Andrew?
Kind of.
What was wrong with you? Are we talking cold, fever, flu,
Sore.
everything?
Dry. Throat.
Do you know if you got it from someone? You were around someone coughing on your face, or you just picked it up somewhere, or what?
Chicken pox.
I think he'd be out more than a day if it was chicken pox. He's tough, but he's not that tough. Did you go to the doctor?
No.
Did
35 euros
you
for
prefer?
10
Yeah,
minutes.
you prefer to keep your 35 euros. Yeah. No, I get that. Fuang feels differently though. She would prefer to spend her 35 euros on
No,
the doctor.
my whole family want me to do that.
Did they pay for the doctor?
No, that's what
If they really wanted you, they should have paid.
yeah.
You can tell them your physics and maths teacher said that.
Both of them.
Both of them, yeah. Yeah. Okay, do you have this now? Yeah. So, what's Ohm's law? You might have heard it before. Bye, so.
I got an email from the principal just for me, so.
Just for you.
Yeah.
Is it the email that says, please tell the students to show up 10 minutes early?
No.
Alright.
So this is important.
Is it?
And she's asking me, is this okay with you?
Does anyone believe him?
No.
Look.
From Klina to Faisal only. There's no one other than Faisal.
She said that.
No.
He's adding in the only part.
Yeah.
Alright. Does anyone know Ohm's law? No?
Yeah. Constantly.
Really forgot.
Yeah.
No, you don't know Ohm's law. You were probably told Ohm's law is V over I is resistance. Or equals V over I, maybe? Does this sound familiar?
No.
No, you were told something else? Good, maybe you were told the right one. Yeah, what is it? What about the graph? Ohm's law states that for some materials at low voltage and low current and a constant temperature, the IV graph
It's right.
will be linear, passing through the origin. This is Ohm's law. This is not always true.
Stupid Ohm. Made a law that doesn't obey.
If it is true, we say the resistor is, make Ohm's name an adjective,
Ohmic resistor.
is ohmic. And if it's not true, we say it's not ohmic.
Non-ohmic resistor.
Okay, and let's check what the slope represents. We already know what the slope represents. The slope is 1 over R. Whoops. Okay, so if you can write this down. Just the definition of Ohm's law. No, you have this already, don't you? Yeah. You can write it twice if you want. So what do you have for breakfast? Cereal? Not Siri. Cereal, yeah. And then for lunch, pre-lunch? No, pre-lunch. The brunch. The meal before lunch.
Oh,
Sandwich, and then lunch? And then after lunch?
nothing, I'm so full.
Oh, good. And then dinner?
I think I won't eat. I'm too fat.
I don't know if just eating sandwiches and cereal is okay.
Sandwich, have chocolate.
Oh, chocolate sandwich. And then also chocolate bar. I think we've discovered the reason.
No.
Oh, yeah, what cereal? What cereal? Yeah! Chocolate cereal, chocolate sandwich, chocolate bar. I'm surprised you only increased by 10%.
No.
And not more.
No, even I also eat a lot of chocolate, but not because in here it has a lot of butter.
Yes, we like butter here.
Yeah,
Yes.
and it's so
It makes the chocolate
Chocolatey.
chocolatey, smooth. Okay. Ohm's law. Have you got this written down? Yeah.
I've been losing weight.
Yeah. Well, you're going to the gym, aren't you?
Like I recently started, but I usually like
I gain muscle. Yeah, 1 kilogram.
I mean, I don't eat any sweets.
How do you know it's not your physics knowledge you've increased in your brain? A kilogram of physics knowledge.
Knowledge is only theoretical. It's not physical. Even if it's physics.
How much did you lose?
I'd say
5 kg?
Oh, too
Wow.
much. Little bit.
no, I'd
5
say,
kilograms?
yeah, like
Look at him. He's wasting away. There's nothing left. What's your gym routine?
No, I don't work out to lose weight.
Yeah, but still, what's your gym routine? Treadmill or
No,
weights or
I'm trying
bench
to gain
pressing?
mass. Yeah, I'm trying to gain mass.
But you're going in the wrong direction. It's decreasing.
No, well,
Maybe
I
you need to
started
eat
2
more
days
chocolate.
ago.
Yeah,
I don't
today
like
is his third day at the gym.
Oh, is that all?
Yeah.
Oh, I thought you'd been going there since you started.
No. I started.
All right. We expect you by the end of the year to be bulked up.
Yeah.
That's what we're all expecting now.
Okay.
Yeah. Big and bulky. Yeah. He's going to be like this in the summer.
Nice.
Yes. And then we'll put you in a wheelchair and push you to class. You can have chocolate in one hand and maybe chocolate milk in the other. Push slowly to class.
And you will feed your grapes.
That's it. Yeah.
But 50 pounds, not much.
No, but you're not tall. You know.
160.
54 is not much for me. Maybe it's more for you. Yeah. How tall are you?
160.
160?
Yeah.
Sure?
Yeah.
Okay.
So it's
So that's good. Yeah.
It's okay. It's okay. Yeah. Not anymore. You've reached your limit.
I will reduce.
What?
I will
Reduce?
Yeah.
More physics will help you lose weight.
Because of the
Yeah.
stress.
The stress. Yeah, the stress will. You'll be sweating the weight off. Okay, here's another example. I will do this one. I just need you to write the table down. I'll answer it now using the computer program. It'll be more convenient. So can you just copy the table, please? And I'll do it. Who else goes to the gym now? You do?
I'm the only frequent
that's not quite the right word. I know what you mean though. We need some other word.
I'm the only one. Yeah.
Yeah, committed. Yeah. Dedicated.
Yeah. They go like 3 days a week.
Good, yeah.
Still not losing weight.
Yeah, but I started losing weight. And now
It's much quicker to lose weight by changing your diet than working out.
Well, I'm not trying to lose weight. Like that's my problem. Like I lose weight way too quickly. Like my problem is with gaining.
What are those protein shakes? Are you taking those?
No.
Tell him why. Tell him why.
I know, you can't leave it hanging like that. Why?
Well,
Tell him. You want to play dirty?
My mom was find me smoking, but she thinks they're drugs and like she basically thinks they're steroids.
She's cool with you smoking, but not drinking protein shakes.
She's not cool with me smoking. She would like me to stop, but she knows she can't do anything about it. But protein shakes are like a drug, it's like cocaine to me.
Steroids.
Yes.
So what you're saying is your mommy won't let you take protein shakes?
I thought they're expensive.
They are expensive, yeah.
Like
You just have to get your protein by drinking raw eggs and
that's what I do.
And Rocky
Thank you.
Greek yogurt, yeah. Alright, settle down now. Okay, did you copy this table? Yeah? Okay, so the first one is Come on. The first one is draw the circuit, but I don't need to do that because we drew the circuit earlier. The second part is draw the curve. I already have the curve drawn, but I just need to change the numbers. Let me just move this over here. So, what is the voltages now? What's to start with? 10 to 1. So it's the current that's different. What's the first one?
14,
Yep.
13.5, 15, 12, 11, 10, 8, 6, 4, 2.
Okay. So do you notice now you don't get a straight line? I should remove this line, but I don't know how. Instead you do what?
Parts of it. Line.
Why is it
And then
13.5?
No, right click.
Oh, come on.
No, right.
I'm right clicking. Thanks, guys.
Right click on the line, not on the
Just
point.
leave it.
Yes. Right click.
We know what you mean.
Format.
It doesn't matter, screw it. Right, so you get a curved shape instead. So you don't always get a straight line. So this resistor, ohmic or not ohmic? Not ohmic, because it's not a straight line. So could you just sketch this in your notebook beside the table, please?
Well, how come, like it's 13.5 then 6, and that...
Different material. Each material behaves differently.
Oh, they're different materials.
Yeah, they're different resistors, which we'll talk about that in a moment.
Sketch it.
Yeah, rough sketch.
Question.
Yeah.
Does the ratio point on the line is straight, parallel to the horizontal?
Depends on the material. You're saying will it flat level off?
Like will it reach a limit of conductivity?
Well, that means.
But I don't know if it will actually shoot up to infinity at some future point, because if you increase the voltage enough in the resistor, you'll blow the resistor and break the circuit, causing infinite resistance, you know. So I don't know, it might level off and then at some point just go poof, sort of like a limit that's been reached, because you can't just keep increasing the voltage. The resistor will eventually blow.
Yeah, but if it levels off, then that means there's no resistance.
No, that means there's very large resistance, because the slope is 1 over R. So a level graph means high resistance. Yeah. So I'd say it won't completely level off. It will start to flatten out, and then I suspect it will then completely flatten horizontally when it reaches its limit then. But it's not maybe really appropriate to draw the graph because the resistor has blown. Okay, next part. Calculate the R. So here is the R. It's in ohms, and the formula for R is V over I, isn't it? Yeah, so it's this divided by this. So on your table, can you add an extra row for the R? And here are the values. Now wait, before I calculate them, what is happening to the slope? Increasing or decreasing as I move? So the R is...
Yeah.
It is increasing because, look, you have to start at the bottom and move up, because you start at 10 and you go to 1. So as you go from 1 to 10, your R increases from 0.5 to 0.7. Can you add this to your table, please? Oops, I need to plug in the battery. Come on, could you pass that over to Yahoo there to plug it in? I've decided that's going to be your preferred English name.
Yahoo.
Yeah, I like it. No, the one down there. Don't you like it?
Yesterday you said you don't like it when you don't trust it.
Double meaning.
Why you always there late?
Oh. Did you add that table in, Lee? Sorry, that is part C now.
So, A is
A is the circuit, B is the graph, C is the OR, D, what is the smallest and largest resistance? Smallest resistance? Yeah, 0.5, and largest resistance? 0.7. And finally, is this material ohmic? No.
That's what's happening now,
Guys. Did you write this down?
Fair wealth is white. Where is this? The fair wealth.
Aye.
Why?
Plus ohmic because of curves.
Correct. Okay, did you get this?
Did we draw the circle?
No, because it's the same as what you drew earlier. Okay. You have that? Wrong! Omar!
No,
Do you-
not wrong.
Chen Lam!
Yeah.
Do you have this?
Yes.
Okay. Continue? I want you to try these questions now, and because they're quite short, we'll do them now. Yeah?
How to say straight line?
Linear. L-I-N-E-R. No, after this class there's maths. But I need...
We have 2 hours and
Yeah.
So we're gonna finish at
And 1 hour of math.
Yeah.
But what difference does that make? There's a longer break?
This one's really nice.
Does have any break?
It makes a big difference for me. Trust me, please.
But I bought covers before this one.
Guys, when you draw this, I would like you to do a nice graph with a ruler, please. If you have a ruler, use it.
If not,
Use your finger.
Sigh. Faisal,
Yes.
Lee. Okay. I want you to do these 2 questions, and I want to have beautiful graphs.
They can't be as beautiful as you.
No, I know. I didn't say they need to be as beautiful as... They don't even have to be as beautiful as me. But I just want nice graphs, okay?
we have to train it to unpack.
It's your choice. You can either keep the graph as milliamps and then change the slope into... what's the slope? It would be milli-ohms then, would it? Yeah, have a think about this now. In the first question, guys, look, this is milliamps. You can change it to amps, or if you keep it milliamps and volts, here is, what did I say? This is volts and this is milliamps, and the OR is equal to 1 over the slope, which will equal 1 over milliamps over volts, which will equal volts over milliamps, which equals 1 over milli, volts over amps. What's volts over amps? Volts over amps, think about it, VIR, resistance, so it's 1 over milli ohms, which is kilo ohms. Because milli is 1 over 10 to the minus 3, which is kilo. So if you do not change it, keep in mind that the slope, the R from the slope is now in kilo ohms. Yeah, so just change it.
Yeah.
Work,
What's the physics behind this?
I don't know, what's the physics behind getting a slap in the face? I want you doing this now. Do you have your laptop with you? I will be so kind and generous and let you make the graph on your laptop if you want. I can't be I can't be fairer than that. Right.
That's so much work. Can just use my finger to throw the graph.
Are you really using your finger?
Anyway. And then IV. First one is ohms, so straight line.
What's your name from?
Ruler. Okay.
Could you use this?
Yeah, but just need the.
There you go.
No, thanks.
Now let's do it.
Well,
Oh, okay.
using the data below, draw the appropriate curve. Appropriate, the correct curve.
The voltage needs to be on the X.
Yeah, the most suitable curve.
The right curve.
Curve is line. Line with a
Draw the only curve I taught you today, the IV characteristic curve. B?
yeah.
I.
Yeah, but you're supposed to put the values.
Yeah. Lee, this is the table for it.
Yeah.
Draw. Look, Lee. B. I.
Yeah.
Draw.
So.
Draw.
Down.
Show
Yeah,
me.
this is right. Just add the values.
No. Yes, put the numbers in.
Why don't they start from 0
Because,
and go 1, 2, 3? Why? 10?
no, they could. Why did I do this? I must have had a reason at the time. Oh yeah, because when you're doing this experiment, at the very beginning, the rheostat is set to 0, which would produce maximum voltage in the other resistor. So this is what would happen if you did it as an experiment. And you actually will do this experiment as one of your labs.
Are the IT labs nice?
Or we do the labs in class.
Mr. Ryan said we're going to the IT for the labs.
No, it's
For chemistry labs.
We're going to the IT to do the chemistry, not the physics?
I have the equipment in the office. I bring it to class. You know, voltmeter, ammeter, meter stick. Pretty safe.
The yellow ones?
The yellow ones.
Where is email focus close? Because email is not there.
Emer is in today, but we were in meetings today, so the meetings are finished. She should be free. After this class, you could see her, maybe. So except for Nadir, we have everyone, yeah? Yeah, alright. I'm just going to the bathroom. I'll be back in a minute. Don't go anywhere and continue doing these. I want you to get both of these finished today so I can do the answers today so we can go on to something new tomorrow. Okay? Alright.
What is what? His name? What is Jiangju?
Who wants to go eat after this?
Only if it's you.
Eva.
You're so good.
I'm so gay. No, I meant only if he is going. You are so dirty. Don't play games with me. Shut up.
When will you finish today?
Don't care. Five. Finish at 5.
Better.
Yes, we
The difference. Please have fun.
Oh. Right.
Yes, talking to that friend. أسره أها إهل الذهب Open your phone, open YouTube and search for the ketchup song. This is the name.
Yeah, no.
The ketchup song.
No, it's really loud.
Yeah, but then if you have to transfer because it's
It's been so long. What you do? Transfer into what?
for to find our you can always divide all this stuff out. That's divided by milliamps.
No, it's 500 milliamps.
Yeah, so it's 5 amps.
No, 0.5 amps is 10.
Sarah from the bar now we're here. Lee, I told you to open the ketchup.
Yeah, but I don't know how to.
Yeah. Ketch. First one, the ketchup song. Open. is not English.
That's all. How is it done?
Yeah.
And then,
When you had your birthday in KFC, back when you were 5.
you guys had a clown in KFC and McDonald's on birthday.
A blind motherfucker. I remember.
And it's the same clown for every branch.
What?
It's the same clown for every branch.
Maybe.
So,
Mr. Steven will know. Oh, that's
you know,
bang, bang,
What was that song for?
old song was so nice.
There's only one coming tomorrow
So,
to the match. Are you gonna sleep in court? What time is the match?
oh shit, yeah.
You'll be back by like 7
Hey, the matches are early, 3 o'clock. Yeah,
p.m.
yeah,
3-4 p.m.
yeah.
How will we watch it? Just
Yeah.
How can we watch it?
How are we doing with these? Do you have the first one finished?
Yes.
Great. First one finished?
Do you know the catch-up song?
I might.
I'm sure you do.
You have to. They were
Come on.
jamming to it while you were gone. Honestly.
Sing it.
That's all I hear.
Yes, I know it. In fact, the hand gestures were enough. Omar, you're finished, or which one are you doing? Which part? Have you made the graph, or are you making the graph? Come on, come on. I should let you know that today is the day I have to give your predicted grades to your tutor. So you want to leave a good impression, you know?
will we know?
Yeah, you will.
When?
I can tell you, or your tutor can tell you tomorrow. I don't know. I need to check with your tutor, Emer.
Yeah, you said that you won't give us the grades, you'll give it to her and then she'll tell us, and she didn't know anything about that.
Yeah, I lied. Because I just wanted less work for me to do.
And you ended up doing it.
No, I just didn't want to go to spend the energy to give you the predicted grades if someone else could do it. Come on, you would do the same thing in my position.
Can't you just tell us if the different grades will come?
No, because I have to actually think about it.
And judge?
Exactly.
No, money, nothing, so. Only God can judge me.
Right. It's only God can judge you and Stephen.
How accurate
For the exam, accurate for,
like, for us to get what you say we would get?
He knows that they were.
I know what grades you need. I know what grades you got. I know how hard you're working.
I know what you're capable of.
I think I know this. Sometimes I'm surprised.
Surprised in a good way or bad?
Both. Sometimes people do better than I expect, and then sometimes I'm like, wow, well, that was a surprise.
Well, I got 2 new notebooks, one for math and one for physics.
This will be considered in your calculation. That's a nice graph.
Seriously, I don't know what is B means.
Seriously? Seriously, you don't? B means make a row that has the resistance in it.
What does that mean?
Write the oars underneath.
So it means like this?
Yes.
So what is the B in person?
Draw the curve.
What is curve?
That graph.
So what is I?
Draw the circuit.
What is that? Oh, okay. But how to draw when I don't know?
It's the same as that. This circuit is the circuit that goes with this graph called IV characteristics. No. All right. Are we nearly finished? What graph are you making there, Yahoo?
I'm on the second.
Right.
Do we have to join the join?
Yes.
Even if it's not on
Yeah, and then a curve.
very bad with curves.
Since you all have the first one finished, let's have a look at what you should get for the first one. I'll just go to the program here. What is the voltages? Is it 10 to 1 as well?
Yes.
And the current? The current is not amps, it is milliamps. So the resistance is not ohms, but kilo ohms. What are the currents, please? The first one?
500.
Yeah.
500. 450. And then it goes on by 50s.
Like this?
Yeah.
So your graph looks like this.
Passes through the origin.
So it is ohmic.
Yes, it is.
And we have the resistance included already. Here it is. Here. The resistance is a constant 0.02 kilo ohms.
Why is it kilo ohms?
The reason was this here.
Also, if we want to make it on.
Oh no, if you want to convert it into amps and not deal with kilo ohms, you can. So you could have said this is 0.5 amps. Is that what you did?
Yeah.
Yeah, that's totally fine. So your answer is 20 ohms? which is the same thing as 0.02 kilo ohms.
Oh, okay.
Yeah.
Yeah.
Right. Yes.
Wait,
Which?
no, the question.
The question.
Okay.
I'm not. What is the smallest and largest resistance? Both the same, 20 ohms. And what does the slope represent? 1 over the resistance. Part 2 is the same, except the numbers are different. Can you give me the currents, please? And it's back to amps. And it's back to ohms. So what's the first current? Are we starting at 10 to 1? Yeah, what's the first one? 21.
18.
Yeah, I can read too.
12, 9. 9,
Can you
6,
show
no.
Well, I know! Oh, come on.
6, 4,
3, 2, 1.
boom, boom, boom.
Not linear.
Not linear.
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 How can I spell?
L-I-N-E-R. I spelled that earlier for you.
E-R, not E-A-R.
Sorry, you're confusing me. L-I-N-E-A-R.
E-A-R, yeah.
I want to go. Right. Ohmic? No. And the smallest and largest resistance, 0.48 and 1. And what does the slope represent? 1 over R. And the units this time? Ohms. But what's the units for the slope?
1 over ohms.
Yeah, per ohms. What else are we asked?
That's it. Is it ohmic? We said it's not.
Yeah.
That's it.
So, can I scroll down a little bit? Some materials, some resistors have different graphs. A small, simple resistor will have an ohmic graph. It'll be a straight line. Some materials, like a lamp, will be a straight line at the beginning and then levels off. So does the resistance increase or decrease? Increase. But you have some materials which are quite interesting. They're straight, and then as the voltage increases, the graph curves up, so the resistance is decreasing. Yeah, I know this seems very strange. This is a feature of lights like this. The reason the resistance increases is because it gets hotter. This is a feature of something called semi-diodes, which are used in computers. You want the resistance to decrease as the computer warms up. And then there's some materials that have different behaviors as well. I think it starts off as the resistance is high, and then it reaches a point, and then all of a sudden it becomes low. Yeah. So you just need to know that different materials can have very different graphs, and it's an important property of the material what type of IV characteristic it is. Yeah? Now, there's still 10 minutes.